This is the scenario on interest applications. The first thing you want to do is to put in your name, and then as you go through it, we're going to learn about simple interest, maturity value, finding present or principal rate or time given the interest. We're going to calculate present value, future value, annuities, and amortization schedules. I guess I should spell that right. After completing this scenario, you should be able to use those functions in Excel and then calculate a table. Let's look at this first one. We're going to use the future value formula, I equals PRT, for 1 year. Della Jacobs borrows $1,200 for 1 year at 10% simple interest. Compute the interest. Well, the formula is principal times rate times time is the interest. We have $1,200, and we always enter the rate as a decimal, so 0.10. The time is 1 year, so our interest formula will be equals, and then click on the principal box, times the rate box, times the time box, and you should have the amount of interest that you've earned, which is that $1,200, and then the future value will be the amount of interest plus the principal. Make sure you get both of those added together for that total. Next one, $12,800 is the principal. Remember, it's to enter your rate as a decimal, even though it will display as a percent. And then the time is, the time is 2.5 years. So our future value will be, oh, I'm sorry, this is supposed to be interest. Our interest will be the principal times the rate times the time, and if you notice, you got that point. Next one. Francis Koo is planning to start a business that will export American foods to China. He estimates that he will need $50,000 for his organizational costs, get sample products, and 3 trips to Shanghai. He can borrow the money for 3 years from his relatives and at 10%. Remember to enter it as a decimal. So the amount of interest will be the principal times the rate times the time. But in this case, you also want to know, you also want to know not just, let's just do it this way, R. You also want to know what the total owed will be. Well, the total owed will be the interest plus the principal. Next one. Now we want exact interest on $8 million at 9%. So you have to get $8 million at 9% for 90 days. Now, for time here, we're going to use days. So then when we do our interest formula, it's going to be the principal times the rate times the time. But in this case, since it's exact interest means that it's a 365-day year, so we have to divide that number of days by 365 to get what part of a year it is. And so that means that our interest is time divided by 365. Make sure you notice that the time is in days. Let's look at the next one. Same thing. $625 at 0.081 for 60 days. This time it's principal times rate times time, but ordinary interest, it says you have to divide by 360 rather than 365. So make sure you pay attention to what you're dividing by there, okay? Oops. And notice we got the point there. Charles Peterson, managing partner of a local transportation company, thinks that the company should borrow money to upgrade its truck repair facility. After investigating several sources, he determines that the company can borrow $250,000 at 7.5% simple interest for 180 days. So our interest is principal times rate times time, and in this case, since it says it's exact, we're going to divide by 365. And notice we got the point there. Next one. Steve Teeter took out a loan for $3,500. I'm sorry. The loan was $3,500. The interest was $269, and the time was 270 days. Now, I think the easiest way to solve this problem is to think about it algebraically. We know interest is principal times rate times time. In this case, the interest is 269, the principal is 3,500, and the time is 270 days. So to get the R all alone, we have to divide both sides by 3,500 and 270 days. And then R will be all alone. So on our calculator, we would press fraction key. The numerator is the 269. Oops. And then the denominator will be 3,500 times, and we need another fraction because that 270 is in days. It's not 270 years. And since it says ordinary, we're going to divide by 360. And so that will be one way to get our answer, is press equals, and then you can press the S to D key to figure out what it is. The other way to do it is to use Excel itself as the calculator. So equals, and then we're going to use the interest, the 269 divided by. Now we have to use parentheses because there are two things in the denominator, and if we wouldn't do them separately, that time sign, it would be multiplying by that. The same is true for the second part because that's 270 360ths of a year. So then you close both sets of parentheses and you get your answer. Compound interest is a little bit different. M is maturity value, P is the original investment, I is the interest in per period, and N is the number of periods. So, number of periods in a year, well, if it's quarterly, there are going to be 4 in a year. The nominal interest rate is 6%, but since it's one fourth of it is each quarter, we have to divide that by 4 to get 1.5%. The principal is $3,000. The maturity value, use the formula above, so it's right here, equals FV parentheses. As soon as you get FV parentheses, you can click the FX button and you can fill in the amounts. The rate, it says, is 0.06, but since it's quarterly we have to divide by 4. Oops. The number of periods, it's 1 year times 4. There is no payment, and the present value, if we put in $3,000, notice the answer is negative. We want the answer to be positive, so we're going to make this present value negative because he's giving the money away at the beginning to get back money later on. So the amount of interest will be the maturity value subtract the principal. So if you notice, we got all of those points. Now the effective interest rate, the rate is the amount of interest. The thing people do wrong is they don't take this box. So we're going to take the amount of interest, that $184 or $189, I don't remember what exactly it was, divide by the principal, which is the $3,000 box, and then we get that point also. Now it says, what will her investment be worth in 6 years? Well, there's 4 each year for 6 years, makes 24 compounding periods. 1.5% each compounding. 6% is the nominal rate. 1.5% is the compounding rate per period. She put $3,000 in. We want to know the maturity value, so equals future value of. Let's go to the FX and let's fill it in. The rate is 0.06 divided by 4, which we know is 1.5%. And then it says 6 years times 4, because there are 4 quarters in a year, no payment. The present value is, we'll use the negative again so that our answer is positive. And when we do, we got the point there also. Now we want to compare the First National and Second National Bank. First National compounds quarterly, so there are 4 quarters in a year. Second National compounds annually, so there's only 1 annual in a year. The nominal rate is 4%, and the nominal rate is 5%. But since there's 4 quarters in a year, it's actually 1% per quarter, whereas over here it's still 5%, 0.05 for the year. Come on now, 0.05. Number of periods in the year, there are 4. No, I'm sorry. In the 6 years, there's 24, and there's 6 years in 6 years. The principal is $8,000 in each case. Okay, so let's get the maturity value. Equals future value, remember that's the same as maturity value, and then we can pull down the FX. We've got the rate is 0.04, but it's quarterly. 6 years quarterly, negative $8,000. And then over on the other side, it will be equals FX or FV. Once again, pull down the FX button. It's 5%. Since it's yearly, we could divide by 1, but it's easier to just leave it as it is. For 6 years, we could multiply by 1, but it's going to be the same answer either way. And we have negative $8,000 once more. When we press that, we get all the points there. Next, we're going to figure out annuities. One of the clues to an annuity is each month saves per month. So we're going to find the payment, saves $200 per month into her retirement account. How much will her investment so it's future value, how much will her investment be worth? Well, our rate is 0.06 monthly, we have to divide by 12. Number of periods is 30 years times 12, and she puts in negative $200 each month. She doesn't start with any money. Okay? So at the end, she has a pretty good chunk of change. Now what you want to do is she's going to withdraw that money. So we're looking for how much can she withdraw each month. We're looking for the payment that she can withdraw each month. Well, her rate is still the same amount, 0.06 monthly. For how many years does she want it to last? 25 years, but that's monthly. And she starts with this 209,001 cent. She doesn't end up with anything. How much can she? Oops, we should make that negative so that our answer is positive. So she could withdraw a pretty good chunk of change in order to get that amount. Now, one more thing that we want to do is to use the loan amortization schedule to finish the last part. So we go to that and we look at the problems there. The first problem is Christina Balmori purchased a condominium for $188,000. That was her purchase price, which is the 100%. She made a 20% down payment, which means she's going to finance, $80,000. That's the down payment. She's going to finance 80,000 or 80%. So we want to know how much is she going to finance. So we're going to cross multiply 188,000 times the 80% divided by the 100%, and that's the amount that she financed. F is for financed. Okay. Her monthly payment, we're going to use the loan amortization schedule to figure that out. Her loan amount, we financed the $150,400. We take that amount and fill it in the loan total amount, and then we put in the annual interest rate, which we got from right here. Put in the loan period in years, 30 years. Since she's paying monthly, we'll put that in, and then I put in today's start date. And when we get done, it'll show you over here that you pay each month this amount, and in total you pay that total amount of interest, which is kind of surprising. It's like buying two houses but only getting one in the final analysis. And so you see that as you go along, your payments stay the exact same, but the amount of principal that you pay each month increases, while the amount of interest that you pay at this last month goes all the way down to $871. When you're done, you'll have 35 points on your scenario.